So we will start with the commissural fibers. And to remind you, commissural pathways are ones that link one area of cortex to another area of cortex on the opposite or contralateral side of the cortex. And there are five main commissures that you should be remembering. The first one is the corpus callosum. The second is the fornix. The third is the anterior commissure. Fourth is the posterior commissure. And the fifth is the habenular commissure. And I will be showing you images of all of these commissures except for the habenular commissure. Okay, and now one thing to drive home is just how large the corpus callosum is. So this is the sum total of all the commissural fibers. If I show you a rendering, a 3D rendering of the brain, these are all the commissural fibers. Now, if I remove all the fibers except for the corpus callosum, the main chunk of corpus callosum, that's it. You can see how the corpus callosum is by far, the fibers that pass through the corpus callosum are by far the largest amount of fibers that go pretty much everywhere around the brain. And so we'll start with the corpus callosum. And we'll state that it is the largest and the most important commissural fiber, and it contains more than 300 million axons. It lies at the bottom of the longitudinal fissure. So just taking my cursor, going down through the longitudinal commissure, and the body of white matter that is there is the corpus callosum. Now, you may want to distinguish the difference between the fibers that pass through the corpus callosum and the corpus callosum itself. But for our purposes, this distinction is not terribly important. The corpus callosum is in fact split into different sections. And we start with the most rostral portion of the corpus callosum, and it's important to note that the most rostral portion is not the most anterior portion. Remember that the coordinate system, rostral, caudal, dorsal, ventral, is completely separate from the anterior, superior, etc. coordinate system. So don't think of them together, think of them as two different things. Whereas anterior, superior, etc., that is real world. Rostral, caudal, dorsal, ventral, that's in relation to a body. And remember, rostrum means nose or beak. So the rostralmost portion of the corpus callosum is here, closest to our nose and our beak. The second portion is just slightly superior to that, and it's in fact the most anterior part of the corpus callosum, which is the genu of the corpus callosum. And genu means knee. It's the inflection point of the corpus callosum. And as soon as you continue going and past that inflection point, we get to the body of the corpus callosum, which encompasses most of the corpus callosum except for the last bit, that little bubble at the end, which is called the splenium of the corpus callosum. And we will go through every bit of the corpus callosum and describe it in detail. So we'll start with the rostrum of the corpus callosum, which is, as I said, a part of the corpus callosum which is at the anterior end. It's a very thin section of the corpus callosum which is prolonged anteriorly to be continuous with the upper end of the lamina terminalis. Do you remember the lamina terminalis? Right here. Center. Okay, lamina terminalis. And it connects frontal lobes to each other. The second part of the corpus callosum, which I will talk about, is the genu of the corpus callosum. And that is the curved anterior end of the corpus callosum that bends inferiorly in front of the septum pellucidum. Septum pellucidum. Okay. It bends right in front of the septum pellucidum, and traced laterally, the fibers of the genu form a special component of the corpus callosum. The fibers are given a special name, and this name is called the forceps minor. And so I can show you the forceps minor if I get rid of all fibers in the corpus callosum except for the forceps minor, and I'll show you this in the orthogonal sections, and I will